We're on page 29 and we're looking at a normal probability and we're looking at probabilities from both sides of the curve. So if we look at our example that we've got here, we've got our backpacks and we've told that they are normally distributed with a mean of 3.3 kilos and a standard deviation of 0.3, and we want to find the probability that a backpack weighs between 2.9 and 3.6 kg. So the first thing we're going to do is draw our normal distribution, put our mean in the middle, so that's our mean of 3.3 kilos, and our standard deviation of 0.3 kilos. Now we need to put those values of 2.9 and 3.6 kilos onto the curve. So remember, our mean is at 3.3, so 2.9 is somewhere below that, so I'm just going to mark a point and say there's about 2.9 kg. And the other value, 3.6 kg, is above the mean of 3.3, so it's going to be some value bigger than that, of about 3.6 kilo. So we want to find the area between those 2 points there. Okay, that's what we're trying to find. So we need to convert that to a Z distribution. And remember, our Z has a mean of 0 and our standard deviation of 1. So that value of 2.9 kg, that is going to be the equivalent of some negative Z value. Then our value of 3.6 kg is going to be equivalent to some other point here above the mean. And we're trying to find that area between 2 points. So that means we need to convert both of those two numbers, 2.9 and 3.6. We've got to convert both of those into Z values. So let's first of all start with our value of 2.9. So we're going to have Z equals X, take away the mean, over our standard deviation, which is, in this case, our X is 2.9, take away the mean of 3.3, over our standard deviation of 0.3, and that is going to give us a Z value of I've got to get to the right page. That's going to give us a Z value of negative 1.333. So that means that, just rub that point out there, so that means we've found our Z value, first Z value of negative 1.333. Now we need to find the equivalent for that value, the Z value of that 3.6. So we're going to do Z equals X, take away the mean, over our standard deviation. So our value of X is that value 3.6, take away the mean of 3.3, over our standard deviation of 0.3, and that gives me a Z value of 1. So that means if I go to my distribution, rub that out, that's going to give me a Z value there of, let me just factor about this mean and standard deviation so I can fit it in. That's going to give me a Z value of 1, which is there. Okay, so we've got 2 points there. We've got a negative Z value of negative 1.333 and a positive Z value of 1, and we want to find the probability between those points. So now if we take that Z distribution, I want to just explore that a little bit more. So here's our Z distribution, mean of 0, and we're looking for negative 1.333 and positive 1. Okay, so that's what we're trying to find. On our probability tables, we can find, if I go from that mean of 0 up to the Z value of 1, we can find that piece of area there. And if we look up 1.00 on our normal probability tables, we should find that that value is equal to 0.3413. Oh, I'm running out of space. Let me just undo that and try writing that in again. 0.3413. Okay, so now what we need to do is we still have to find this negative part. So from that mean of 0, we've got to find that negative 1.333. We've got to find out how big that piece there is. Okay, and if I combine this probability plus this probability together, that will give me this total probability that I'm looking at there. So to find the negative probability, we're going to go to our positive z value, because remember the table only gives positive z values, so we're going to look for the probability between 0 and positive 1.333. And this area here that I've just shaded in, show you this, sorry, I'll do another colour. That area there is going to be the same size as this area here. Okay, going between 0 and a positive x value is the same as going between 0 and a negative z value. So when we look that up onto our probability tables, we find that that area is 0.4087. Okay, so now we need to combine those together. So we've got our probability of 0.3413 and 4087. So now we need to write down our notation. So let's write this down using the correct notation. So the probability, if I go back to the original, we wanted to know for our x distribution the chance of being between 2.9 kilos and 3.6 kilos. And that's equivalent to the probability of our z distribution being between negative 1.333 and positive 1. And so that then what we did, we said, well, we found the probability of z. No, I won't do that. Skip that. So we're just going to add those two probabilities, and we're going to say 0.4087 plus 0.3413, and that will give us a probability of 0.75. Okay, so then we just need to write that up in an answer, in a sentence, and we can say the probability of a backpack weighing between 2.9 kg and 3.6 kg is 0.75. And there we go.